Hey, welcome back to the Master Math Classic Math video, brought to you by Mr. Shalongo, the guy who started the Make Math Make Sense YouTube channel. If you haven't already subscribed or liked, go ahead and hit the subscribe and like button. We're almost at 400. No, but seriously, today we got the quadratic formula. We're coming to you live from Betty Fairfax High School. This one goes out to all my scholars. Oh, so many great scholars this year. Let's get into it. All right, so here's the note screen. I encourage you to pause the video right now and get down these notes. We'll go over all of this today, piece by piece. All right, so today we're talking about the quadratic formula. We use the quadratic formula to solve quadratic equations, and it works every single time. Sometimes we'll get real solutions, sometimes we'll get imaginary solutions. We'll talk more about those later on in algebra. But today, let's go ahead and get these zeros. Let's find these zeros. We know that these zeros are the x-intercepts, and here we have this formula that we can utilize to go ahead and find those x-intercepts. Process is pretty simple. First, you want to arrange the quadratic in standard form. So you want ax squared plus bx plus c equals 0. And then we're going to substitute the a, b, and c values in for their respective places in this formula, and we're going to simplify. Let's go ahead and get into today's example. Negative 7x squared plus x plus 9 equals negative 6. I gotta get it into standard form. So I've got to get a 0 on one side. I can get a 0 on the left side, or I can get a 0 on the right side. Makes more sense to get the 0 on the right side because there's only one thing. How do I get negative 6x to 0? I add 6x to both sides. I'm writing it under the middle term because that's what I'm going to combine it with. And after I do so, the new quadratic equation is negative 7x squared plus 7x plus 9 equals 0. So we got process 1, the first part of the process, done. It's in standard form. Now the second part of the process, we identify what A is. Boom, there's A. Boom, there's B. Boom, there's C. If we use highlights, I'm putting that negative 7 in for those two A's. And I'm putting in that positive 7 for that B right there and that B right there. And then C only has one substitution. This positive 9 is going right there. Alright, so I've got the first part of the second step completed. I've got everything correctly substituted in, and now I'm just going to start simplifying. So I got negative 1 times 7 is negative 7, plus or minus, this is all over. 2 times negative 7 is negative 14. And then I'm going to leave this number, I'm going to leave this under the square root. I'm going to figure out the value. I'm going to go ahead and use Desmos to do so. Alright, so I plugged in the expression that was under the square root, and we got 301. So from here, we're just going to keep trying to simplify if we can. There's not a whole lot to simplify. We're going to check to see if we can find our answer. If we can, we select it right away. It looks like this is an example where we can select it right away. So sometimes you might have to simplify, sometimes you won't. This is an example where there wasn't much more that we could simplify. So you choose your answer and boom, you move on. Alright, let's do one more example, and then I'll go ahead and show you how you can verify your answers in Desmos before you select in Con, just to make sure you got the right answer. So we have this example, negative 7x plus 1 minus 10x squared equals 0. We've already got the 0 on one side. The problem's giving us that 0, but this isn't in standard form, so I'm just going to rewrite it in standard form. We got negative 10x squared goes first, highest to lowest based on the exponent. And then obviously the number without a variable, the constant, is always last in standard form. So now we've got it in standard form. We can start moving in to our second step, substitute and simplify. So we got A, we got B, and we got C. Alright, so I'm going to go ahead and simplify this. We got negative times negative is a positive. We got positive 7 plus or minus the square root, the square root of, so we got negative 7 squared, which is 49. We got a negative 4 times 10, which is a positive 40, times 1 is a positive 40. 40 plus 49 is an 89, so we got 89 under here. Use Desmos to do that part. Just did that so you can see what I'm doing. 2 times negative 10 is negative 20. Now we're looking to see, do we have our answer? Is it showing up right now? It is showing up. It's right here. Bada bang, bada boom. Now, if I wanted to figure out whether or not this was going to be right or not, before I hit check, there's absolutely a way to do that. Let me show you. So in Desmos, I'm going to type in the original equation. And there's our two answers in these crazy decimal forms. And we just got to figure out which of these four would match up with these lines. So we get two answers, two lines. Now you can't plug in a plus or minus in Desmos, so you can only check like the positive or the negative. So I'll type in B, because we know B is going to be wrong. So we'll see what it looks like when it's wrong. Square root 73 divided by 9. And you can see I forgot the x equals part, so I'm not getting the line. Let me put that in there. Now I'm getting the line, and that line's not matching up with either of our answers. So we know, okay, cool. If the plus isn't matching up, obviously the minus isn't going to match up either. So now I'm going to adjust it to the answer that we solved for algebraically. This -1 should be a 7. We'll leave it as a plus. Make this an 89, and make this a -20. And you can see as soon as I type that in, it's matching up with the lower value. And if I change this to a minus, it's going to be matching up with the right. And so that's a double check. If you would like to double check, that would be how you double check. Okay, so the second part of today's lesson is using the discriminant. Okay, so the discriminant comes from the quadratic formula, and I'm going to go ahead and highlight using this color. The discriminant is just this part right here. I'm going to go ahead and write it out because I like double highlighted everything. Classic Shalongo, classic. So the discriminant is b squared minus 4ac. So just this part right here. And with the discriminant, it doesn't give you the solutions, but what it does give you is it gives you the number of real solutions that the quadratic would have. So you can have a quadratic with 2 real solutions, you can have a quadratic with 1 real solution, and a quadratic with no real solutions. And then you can kind of see the graphs that go with those solutions. Like 2 real would be if it crossed the x twice, 1 would be if it touched it once, and then no real solutions would be if it never crosses the x. That means that this has an imaginary solution, right? And so we can use the discriminant in order to determine how many solutions, not what they are, but how many there would be, how many real solutions there would be. So the discriminant, when we plug in b, a, and c, if that number comes back as positive, then we know there's 2 real. If that number comes back as 0, then we know that there's 1 real solution. And if that comes back as a negative number, then we know that there would be no real solutions. So I've got the quadratic. It's already in standard form. I'm going over to Desmos. I'm typing in the discriminant, b squared minus 4 times a times c. I'm making sliders here. I'm dragging the a up just so that it's in alphabetical order. And then I'm adjusting what the a value is. So the a value is in front of the x squared is a -4, changing this to a -4. The b value in our problem is 12, changing this to a 12. And the c value is -9. So Desmos substituted these numbers into our discriminant for us up here, and we get back 0. What is the value of the discriminant? The value of the discriminant is whatever that number is in right there. So we're going to type in a 0. Then the second question says, how many x-intercepts does the function have? So I'm going to go to my table. I'm going to using this value, I'm going to see where it fits. Is 0 a positive number? No, it's not. Is 0 0? Yes, it is. Is 0 a negative number? No, it's not. 0 is 0. So how many real solutions would this have? This would have 1 real solution. Now, if that part's confusing for you, then you could just graph the quadratic, -4x squared plus 12x minus 9, and then you could just look to see like how many times does it cross the x. Oh, it's crossing the x 1 time, and that would be how you get the number in the second box. Let's do one more example today. This one's kind of an easy, so we'll just go through this one quickly. Is the discriminant positive, 0, or negative? Going to my notes, and I'm looking at the graph. Okay, cool. How many times is it crossing the x? It's crossing none. Cool. If it's crossing none, then it would have a negative. Then we would have a negative discriminant. Boom, done. Check negative, and pause because I can't hit the check button. And last example for this video today. We got a 10-minute video rocking. Definitely want to avoid making 10-minute videos. Probably going to delete this one later because it's so long. But this one's definitely for my 7th period scholars because I love them so much. So I've got the values in. A B, and C. The value of the discriminant comes back as 241. Sweet. 241, what type of number is that? Is it a positive number? Is it 0 or is it a negative? 241 is a positive number. So how many zeros would a positive number for the discriminant have? It would have 2 real solutions, or two zeros. Boom. And I hit check, just so you know that I got it right. Boom, boom. And that's what we got for you today. Quadratic formula and number of solutions to quadratic equations. Good luck.